Greetings programs. In this video, I'll be covering the basics of how to use Quad Spinner's Gaea landscape generation program to create landscapes and color maps and other utility maps for use in Lightwave 3D. So without further ado, let's get started. I've created a quick base landscape here, which I'm going to start by opening up Gaea. Once it loads, I will move it over to the right window. There we go. And what you have here is a very minimum landscape. You got your basic mountain node, which creates a nice little mountainscape here. And I'll walk through the seed values and settings until I found something I liked, which is a nice little mountain here, a little bit of valley, a little flat spot that I could use to put a river, and then basic default erosion node, just using the standard defaults you see here. And what we're going to do is we're going to color it, and then we're going to render it, and then pull it into Lightwave. So I'm not going to go into the depths of Gaea here. I'm going to assume a little bit of knowledge, that you have a little bit of knowledge of Gaea 3D, and everything I show you will be functional with the free version of Gaea. The only limitation on the free version of Gaea is you're limited to a 1K by 1K resolution on the images, height maps, and the mesh itself that you can output. The paid version, even the lowest level paid version, will output all the way up to 8K. Unless you've got 64 gig of memory or higher, you're not going to output anything more than 8K, and currently 16K is as high as it goes. In theory, you can go higher than that, and once they get tiled, true tiled rendering out, the sky's the limit. So, and to be honest, I'm looking forward to that. So, see mountain here, erosion. And okay, it's pretty, it's a landscape, but it's not really that useful at this point. So let's throw some textures in here. Yeah, texture. Now this texture, yes, I know, is not the way we think of texture. This is what's called a data map. And you scroll down here, you see your data maps, and this is a texturing data within the landscape. It's not a texture like an image texture, or the way we're used to thinking about it in 3D. So some of the terminology inside Gaea can trip you up. I'll explain what nodes to export to be used to use in Lightwave as we get to them. The first thing we want to do is want to select the last landscape node, last height map node that builds the actual landform itself that we're within our graph, which in this case is the erosion node. Select as pin as underlay, and I want to select for export because I want that height map. And come here to the texture. Don't really like that one, so I tend to like C texture type, which will show you here in a second. You see the changes. It gets a lot of detail, a lot of contrast. Let's play the numbers here a little bit. Let's just leave those where it is. Apply the changes so you can see it. And there we go. Now sat maps is where all your color comes from, and these are satellite maps. These are you can't generate these yourself yet. But it comes with hundreds of them. You can generate your own gradient maps within the package using the clutter, and that's something for the advanced guys out there doing advanced Gaea tutorials, like Dylan Yarbrough and Dax Pandy. They got the owner of Quad Spinner and a few others, and I'll link to a few others down below in the comments or in the description under the video. But Dylan Yarbrough has a paid set of videos that and actually an annual subscription if you want on Gumroad if you want to go that route. That are well worth it, absolutely well worth every penny. Um, so, but let's attach that here, color, and that's horrible. That's awful. Um, so for this first bit of texture, what I'm looking for is kind of a tree, yeah, kind of forest with a little bit of mountain landscape on it. So for the first one, let's go with a rock a bit. So let's go to rocky. Um, let's scroll up. So we got, let's say, that one looks good for rock. And that gives us our nice rocks along here. And right now I'm rendering everything at 512K, which just for look, just for speed purposes. You can go to 1K if you want, if you got a fast enough machine. But for this initial layout like this, I typically stay at 512 just to. Because all I'm looking at right now is this color. As you can see, some of the nodes are compute intensive. Yeah, you can see more detail there, but that's not useful to us at this point. So, back to sat maps. And we'll come back and adjust this a bit in a little bit here. Now that's that's still not useful. We need some greenery. So let's pull another texture node. Where's my data? And this is the beautiful thing here is you can just layer these things over and over and over. Another texture node. I like A there again. So let's leave that. Let's leave that where it is. Let's let's leave that where it is. Let's pull a sat map. Get some color in here. Here we go. Let's go up here to the greens. And there we go, some greens and browns. And yeah, let's play with that one a little bit first before we go any further. Set on jitter, get a little bit of noise in there. Auto level coming in, that's good. And yeah, it's looking pretty good. You got some dark forest here, you got some lighter, got this. And yeah, it's colored our rock here, which is brown, which is okay for now. And we want to we'll keep some of that. But you see you got your rock detail there and the green on top of that. Now, let's mix them up. Let's go over here to our color mixer. And yeah, that's not really looking that great. So let's come off this second texture here, which is our primary texture. That's the one that's on top of the rock. And see what we get. And let's blend that a bit. Let's flip the inputs. There we go. And bring that up a little more, a little more. Yeah, that's not bad. You can definitely see the difference where that rock detail's coming out. It's still getting a little bit of the brown color there, coloration there. Because this type of landscape with that much greenery, you're not going to get that hard gray alpine black and white granite. So think of this as northeast U.S. Adirondacks kind of landscape. But there you go. So we got that a little bit. Let's go back and play with this greenery a little bit here. I'm not too happy with it. And actually I'm not happy with that mix either. So let's throw it in auto level, which does more than just auto level, and play with that masking a little bit. Keep the nodes all nice and organized. And yes, I know nodes. There are those out there that don't like nodes, but it is the world we live in now. And to be honest, I like them. Um, all the way back to Amiga Vision in the late '80s, early '90s when this type of concept was I first saw this kind of concept. We use blocks of code that you can connect together and pass data back and forth. It's a wonderful thing. So there we go, auto level. As you notice, auto level get your texture. Doesn't really seem to be doing much. So let's play the gain a little bit, which is kind of like the contrast for these in a way. And yeah, there we go. Yeah, I like that. Now, one thing you can do here is I can pin that, come back over to this one, and as I move this, let's drop that to the floor. Um, you'll see it update color, so I can see in real time what I'm doing. I don't have to keep bouncing back and forth between the nodes. So if I want to bring that way down, but yeah, yeah, I'm getting a weird little thing there. So let's pop up in resolution to see if it's still there. Sometimes you'll get little artifacts like that at low resolution. There we go. Yeah, get a little bit of that gray, old stone gray, um, old gray stone peeking out there in the river and kind of the erosion valleys and stuff there, which is actually kind of pretty. I'll leave it there. Let's drop that back to 512. And see if we need to adjust the blend at all here. Yeah, 75. Now, there are other blend types we can use, but if I want to more of, yeah, let's bring that down a little bit more. There we go. There we go. Now, one thing you got here is this little flat piece here, and you can see it really pops at this point and over here. And I want to make that lake. I want that to be water. And so what I want to do now is I want to drop a slope because that's flat. What you see there, that's flat. So I want to mask out that flat spot right there. And so I can bring on a slope. Again, pull it. And what I'm doing is just take the data from the erosion, which is my landscape, this height map, and operate on it. That's all these data, all it does is it takes whatever you on the left of the string and does something to it, and that's the map you've got here. So let me unpin this so I can see what I'm doing. Okay. And a slope. And slope's gonna be kind of interesting because minimum. Yeah, there we go. And the slopes are in degrees. Okay, I'm going to go up in resolution on that one. So that's kind of important here to make sure I'm not missing any of the landscape. Yeah, I'm missing a good chunk of there. Let's bring the fall off up a bit. That'll give me a little bit of a blurring on the mask on the edges there. And let's come up about 3 degrees on that one and drop that down to 1%. There we go. Yeah, there we go. Yeah, that's looking good. Okay. Yeah, that's good. Now we got some color. Let's make it a. Let's pull this map out here again. Make it some color. Come back over here to sat maps. Go to blue. And that's horrendous. Even if I reverse it, that's kind of horrendous. And let's go to that one. And let's come in kind of tight. Let's flip that back around where it belongs. There we go. That's what I want. Is I want a little bit of greenery on these edges. Come up there. There we go. Yeah, there we go. So that way it'll blend in with the forest a bit. Let's bring this up some so the same thing on the colors better. And bring that back out. Let's have some jitter. Yeah, there we go. Yeah, I don't like that. There we go. Okay. And we've got a color map. Now, what to do with it? We got to mix it back in with our final map. So let's pull in another mixer. Stop that. Yeah. I changed resolutions. It didn't tell it to rebuild those nodes, so we got to wait for it. Okay. Input. Input. And since I'm mixing this on the slope, there we go. Now that's I don't really like that, so let's play with that some. And 100%. There we go. Play with that color for a minute here. Yeah, there we go. Okay. Now, and I'll explain in a minute why I marked the slope for export. And we do want, this map will become very useful in Lightwave, and I'll explain why when we get over there. And our final color is this one here. Now, we can just take this one as is and take it right out of this mixer node as a RGB or sRGB color. If we wanted to manipulate it at all, we've got a node called Color Effects. Oops. Which gives us brightness, contrast, hue, saturation, auto level, gamma controls, all kind of stuff. But I want this raw color right out of here, so we don't need that. Okay, this is a good point to save it. So save this as tutorial. And now we can go from this. This is all you really need at this point because I have heightfield, which you can use as a displacement map to create your landscape. And I have my color, which you apply to the landscape. And then I've got a map that I can use to mask the roughness and specular in the surface settings so I get nice reflective water. Boom, we're done. Except we also have the ability to generate a mesh right here in Gaea. Now the mesher node outputs an object file, a point cloud, which is used primarily, I think, in game engines. I've never really had a reason to use it. I've not explored it too much. And then Autodesk FBX. But since the FBX export calls on an external program that takes an object file that it exports, feeds it to an external program, then exports an FBX from that, I just export as an OBJ. Since Lightwave handles OBJs no problem. So I'm not going to go through an extra couple of steps and extra time for an FBX file. So we're going to deal with OBJ files here. Now, a word about scale. Gaea doesn't understand scale. There is no real world to this within the package itself. Some of the nodes, the erosion nodes, and some of the other more advanced nodes do have an idea of scale, feature scale, real world scale that come into play. But as far as up till now, the physical size of the landscape is 0 to 1. It's a unit scale. Now, at this point, the defaults are a terrain definition, what they call a terrain definition, of 2,600 meters high from 0 to 1. So 1 is 2,600 meters, and a landscape width and height of 5,000 meters. And that doesn't really mean much, except when we export, if we export as raw or export as proportional on the mesher node, what we get is a 2,600 meter by 5,000 meter object in Lightwave if we select the 1 unit equals 1 meter here. And since that's what we're going to do, that way we don't have to worry about scaling things up and down in Lightwave. We don't have to worry about resizing stuff. We can just pull it in and go. That's the way I'm selecting it. Vertex count. This is the number of points along the x and y axis of the object that it's exporting. It's not number of polygons. I'm gonna leave it at 1024 just for the sake of speed at this point. I do not use force quads. There's no need to. I like triangles. It does triangles beautifully. And that prevents the need to triangulate in Modeler. And we all know that Modeler handling very large models can be a little slow. And if you go with quads, you end up with non-planars. You're guaranteed non-planars in a landscape this shape. So I leave force quads off. And when it says create walls, we're not going to have that problem here with this because we're flat on the edges. But if you had a landscape that had, say, that was tall on one side, taller on one side than another, you would have you could create walls where it would flatten out, or you have this wall down each side. Again, I'll leave that off. If I need that, I'll do an extrusion over in Modeler. So, and levels of detail. This is nice in that it will create. At this point, it'll create 5 models for us. It'll create the one we asked for, which is 1024 by 1024, which is, again, number of vertices, number of faces, and then have that for the next level of detail. Have that again, all the way down. And for look dev and for just basic layout and blocking, I'll often start with it. I'll often work with these lower dev versions, and then just substitute in the full res version for the final image. Or for a couple of scenes I'm working on for a book cover project, I've got the up close hero landscape is at 4K, which is a full 16 million vertices. It's an insanely detailed landscape, but the other pieces in the scene that are much further away are much lower resolution, and I've got one way off in the distance that's just a hint of a mountain peak that really is 128 by 128. It's just a little bitty. There's no detail to it at all. It's just a hint of color, and it's half of the landscapes objects in that scene are all the same object, just rotated in different directions, um, and rotated, stretched, manipulated in some fashion. So, but the levels of detail are handy here. So, and I'm going to create them just because, just to show you the difference in the detail what you get in Modeler. So we have, and you can I mark it for export, although if it's there, it's going to export anyway. It's not really a bug in that it doesn't break anything, but it's a feature. You can't not export a mesher if it's in the program, if it's in the graph. It's a little frustrating at times because it can be slow, but you get used to it and just it's there, it's there. But I mark it if I want to export, I'll mark it for export. So now there's one more little thing that I do that I want to do here, and this is a part of the data nodes, and that is a detail node. This is not technically what I'm using it for, something that's not technically meant for, but it is. I have found it to be a very useful little bit of imaging. And yeah, it's black. That there's no data there, right? Wrong. There's a lot of data there. What this does is you set the target scale to the vertex resolution of your target mesh. In this case, 1024. And what it does is it gives you all of the detail between the resolution of your render, the image resolution of your output, and the mesh output. And it's all the extra little data that you're losing. It's giving it back to you. And yes, I'm going to use this as a bump map. It's not exactly a bump map because you see here in the flats areas here or there, we're missing some stuff, and it's not a perfect bump map, but it gives you that. Lets you play with it in surfacing to get you that extra little bit of detail you need for realism, and especially at lower resolutions like we're working with today. And an 8K version of this detail map, there are times I'll render out an 8K version of a color map and a detail map to use with a 2K mesh, and other very low resolution like 1K utility maps like that, like the slope mask, 1K, things like that. One for memory utilization inside Lightwave, and also for just render speed as I iterate through versions of this of my looks that are just beautiful, beautiful bit of detail. But we get our detail here, mark for export, and there is this also. Gaea will also output a normal map. However, these normal maps are screen space or object space normal maps. They are not useful for us at all. Lightwave uses what's called vertex space normal maps, which means the normal directions, the normal data, is based on the direction of the modification of the direction of the normal of the polygon itself, rather than a modification based on the global normal, the basic normal of the object or of the screen in which the object exists in. And there is no real way to convert those inside Lightwave. There are external programs that will convert from screen space to vertex space. Substance Painter, for one, will do that. You're better off in using something like XNormal to take a very high resolution, like a 4K or like a 4K mesh out of here, or 8K mesh out of here, and the 2K mesh or something, the mesh that you're actually going to use, and use that to generate the ultra high res mesh and the low res mesh, the usual mesh, and use that to generate your normal maps, your vertex based normal maps, rather than try to use the ones out of here. It is on the roadmap coming up maybe later this year with 1.3 or later version to get us be able to generate a vertex space normal map. But the way Gaea works is it is a height field generator. That normal data doesn't exist. It really there's no data there for it to generate the normal map from. It's height field. It's distance from zero for that point on a two-dimensional grid. That's effectively all you're getting. And the mesh that it's generating is converting that to distance height from zero along the vertical axis for that vertex for that mesh. And that's effectively all you're getting there. So there's no knowledge of normals or normal direction or detail normals or that type of data within Gaea itself, at least not yet. Quad Spinner has been fantastic for responding to requests and pushing the envelope on what they can do. But there's a whole lot of things on their roadmap that I think are a lot more important than giving me a normal map that I can generate any of a half dozen other ways outside this. So, um, but if I'm wrong or if there's other ways to do it, leave me comments down below, yada yada, subscribe, all that other stuff. You know the drill. Um, hit some buttons on the screen and make me happy, or at least make Google happy. So here we go. We have our color map. We have our slope, which is our water map. We have some details, which we're going to use for bumps, bumpity bumps. And we have our mesh output. 1 unit per meter, 1024 by 1024, a whole bunch of other copies of it. Over here in our build window, I'm just going to leave it at the default location for building for now. And I'm going to be doing another series of these where I'm going to walk you through an entire project involving Gaea, Megascans, DAZ 3D, Lightwave, from start to finish on a cover concept art project I'm working on, where I'll go into a lot more detail on build destinations, utility maps, look dev iterations, and really making Gaea a core part of your tool set. But that's coming in a couple of weeks. So height map 2600 meters, scale 5000 meters, range raw, I'll leave it there. You can use proportional, normalized, remapped. There are other videos to go over more detail on that, and I can go over more detail in a future video. But it doesn't really, I just leave it at raw for our purposes today. Leave it at raw. Additional options, tiled output, don't mess with it. This is not tiled rendering. What this does, it takes the this 2048 resolution, which I'm going to drop to 1024 just again for speed purposes, and breaks it up into this many tiles. Okay, so basically it would give us a 2x2, a group of 4 tiles of this final render. Tiled rendering down the road will let us do, say, a 16K render that will break it up as, say I want an output of 16K by 16K rendered in 4K chunks, and it will render a 16K wide output in 4K chunks. So, see, ignore that. Advanced options, do not resample. These are for game engines primarily. 8193, 8129. This is Unity, and Unreal have some really weird resolutions that they deal with at times. I understand why. I'm starting to get a kind of a grasp on why on some cases, but I ignore those. I leave them alone because in Lightwave they're not relevant to us. Color space. This is for color nodes. Your data nodes, which are your orange nodes, and your yellow nodes, and a green node, for instance, they're always output as RGB, as linear. Your color nodes, your mixers, anything with a color in it, will output as sRGB or whatever you select here. sCRGB is an extended sRGB. I've never seen anything that supports it. I've never played with it. You can play with it, have fun with it, dig into it, but today we're going to do with sRGB. Mutations is interesting. Let's say I've got this landscape and I want 5 iterations of it. And this one would be simple for that. It would give me 5 copies of the same thing because I've not done any manual manipulation with manual paint-in masks or anything in here. I can get 5 versions of this, 5 different iterations of this landscape, and what that does is it mutates the seed values of the nodes in this landscape that have seed values, and X number of times, and saves X number of versions of this same build. Build 1, build 2, build 3, build 4, build 5, iterations of that automatically for you. So I could get, right now I could do, if I wanted to do this and go to dinner, I could do 100 iterations of this landscape overnight and come back and I have 100 different landscapes. But I'm only going to do the one. So, but we are ready to render, except one more thing. Color mixer. can name things if you want. Right now, I'm just going to leave them at the default names. You right click on it, select a name, and let's rename it. Whatever. Landscape color, yes, I want to rename it. It does that. Erosion, let's rename that. Final height field. Let's rename the details. Bumpy. And slope, I'll rename to water mask. At least that way, when I get into Lightwave, I'll have there's some semblance of what they're being used for. So you can see over here they've already been renamed. Now, I always leave my data maps and height maps at TIFF. There's multiple versions of things you can export. There's TIFF 16, which is a 16-bit TIFF, which is new for this version of Gaea. TIFF is TIFF 32, it's 32-bit. There's PNG, which is PNG 16-bit, and there's PNG 8, which is PNG 8-bit. I'm going to do PNG 16-bit for the. I'm going to leave this at TIFF 32, and leave these at TIFF 32. Then I'm going to do the color at PNG 16-bit because I don't need 32-bit TIFF color for this color space. Sometimes I'll do PNG 8. EXRs are just, I don't need those for this. If I was using the height field for the displacement, I would use an EXR for that, just to get that extra little oomph of floating point data in there. But the TIFF data, PNG, and we're now good to go. Let's save that out again. I'll hit the plus to save. It saves an iteration of it, so it's now tutorial 01. 1K, build, location, resolution, and we start the build. Now here's the thing, we're already looking at it at 1K. We're asking it to build at 1K, so everything is already cached at 1K except the mesh. It's going to have to build that instead. So preview resolution is the same as a build. It's already built. Would you like to save the cache build instead? And if you want to, yes. There are times when you don't want to, when you want it to rebuild that cache. And this time I want to say no. I want it to rebuild everything from scratch. But when you're doing like your look iteration, especially like changing things like your masks and stuff, and you have one node that gets updated and nothing else has, this is a lifesaver. You're only rebuilding that one node, and it's especially if you're working at your visual resolution. That's why I work with a lot of my masks in my utility, like the slope mask, things like that, at 1K or 2K, so I can see them and then I can just rebuild them, and it's fast. That's the only thing that gets rebuilt and saved. So let's. Would you like to save the cache build instead? No. And there we go. And while that's going, I'm one of those old gray beard pipe smokers, so I'm going to relight my pipe and get that going again while this builds. Nothing better than sitting watching a render with a nice Peterson Cavendish full of or a Peterson Briar full of vanilla Cavendish. And the render is done. And with that, we are done with Gaea for now. So, and here's what we get out of it. Files. Look at that. Oh, thank you. And we have our 5 meshes. We have our water mask here. We have our landscape color. We have our final. Now, the height field is this. This is your landscape height field. And the erosion node also has 3 other data fields that it outputs, and that's the deposit, the flow, and the wear data of the erosion data, which there's no reason not to turn those off. There's no way to turn those off, so you always get them. In earlier versions, you could turn those on or off, and there may be a way to do that now, but I ignore them, and they may come in handy. That's a neat little bit of data there you might be able to play with. The deposit node is interesting, and that's where all the deposits from the erosion came down. So if you want to play with that, use that to play with for I don't know, grass, a weight map for grass or something, or dirt or whatever in your surfacing. It's the data's there. And then here's our wonderful. God, let's pull that up big. Um, there's that detail map, 100%. And now let's go into, let's pull that aside for a moment, and let's pop over to Modeler. Let's grab the mesh, pull it in. Take a minute to load because it's Modeler. And loads and loads and loads and loads. I normally would load this into layout first to do the surfacing and conversion to Lightwave object format, which layout will load in OBJ a lot faster. Lightwave, well, layout 2020 will anyway. I did time 2018 at one point, and there's not much speed difference, but 2020 seems to operate a lot faster for things like this. So the engine's getting faster over there. I'm looking forward to some updates, some of the improvements in Modeler now that they've started working on expanding it again. So, all right, we got our measure, and there we go. Look at that. We have a landscape. Now comes the interesting things about Gaea that I need to show you. We're not. There's some interesting little quirks in Gaea in the way it builds its meshes. And the first one is how it handles its UVs. Yes, this has UV maps on it. And take a moment here to show this. Pull up the UV map. Okay, nice little UV map, nice and dense, right? There's a problem. Okay, I'm looking at the top of it here, and I select that group of things. What do you notice? Yep, it's rotated 180 degrees. This is something you got to keep in mind. If you're applying maps from elsewhere, or you are applying maps and not using UV maps, or using planar mapping or some other mapping method onto this landscape, and things have to line up, you've got to rotate the maps 180 degrees. If the map's coming out of Gaea and you want it to line up, you've got to rotate it 180 degrees if you're not using the UV maps, UV mapping. This is critical when you're dealing with weight maps and some of the utility maps, and when you're using maps elsewhere that are coming from other sources. It's critical to keep that in mind. Now, if you're using straight planar mapping, it's straight planar mapping. It doesn't matter. And if you're using just a grid generated and created in layout and then displaced, you create the UV maps, UVs yourself, and you're fine. But if you'll notice on the height field here, or rather let me pull this back up here a minute. Where is it? Okay. If you remember, this empty plane here where I had the water masked out is the bottom left. Same thing with the mask. So these are 180 degrees off from the generation of the mesh. But the height field is correct with the rest of the maps. So the mesh is what's backwards. Don't know why. It's been that way since day one, and I've reported it. It's not really, again, it's not really a bug. Apparently, it doesn't affect other some of the game engines or wherever, some of the other target packages. But and it's you apply this with UV map, and everything lines up properly. Because as you saw, the UVs are rotated. So you could rotate them if you want yourself, if you want to, but then nothing lines up. Then you have to rotate your maps. So, but let's add some surfaces. Drag our maps in. Image editor. Linear, as you notice, there's no change in linear. If I set that to sRGB, not gonna notice there because it's basically 2-bit. Okay, it gets dark. Linear is what you want. Landscape color, sRGB, no change. It's already embedded. Okay. Default. Shading model, glossy. Smoothing, double-sided. All right, materials. I'm just going to do a basic here and then we'll take it over in a layout and pretty it up. So. This modeler can get kind of slow with large meshes. Not that I consider a million polygon mesh to be large, not today. Pull something, a really detailed mesh out of ZBrush and tell me that a million polygons is large. Okay, image. Landscape color. UV map. Come on. UV map. Never understood why it does all of this processing and back-end updating of the entire screen and the entire display every time you select something when you're not plugged into the surface. I haven't modified the surface anyway, but it is what it is. Luminous color, it's because it's your habit. If I want to make this thing glow, it's there. Bumpy. Okay, because of how bright that is and how heavy that data is, I have found that about 5% is good. More than that, and it gets a bit obnoxious, especially at low resolutions like this. Okay. Now I'm not going to set up the roughness and specular map off the for the water yet. I'll do that over in layout, but I at least want to get the image in here. Oops, wrong one. There we go. Okay, we now have a landscape. 2 million vertices. 2 million vertices. Just over 2 million faces. There you go. Save object as. Cut and paste that. Or copy that. Make it easier. Save it. this is what we're going to be dealing with in the end. This is what we're building. And I'm about to clear this scene and start over so that you can see what we're going to get to. Let Viper VPR do its thing here. But I want you to see what we're aiming for so that I can, and then I'll walk you through how I got there. This is not that detailed. It's a little rough, but again, we're dealing with a 1K mesh, and we're dealing with 1K by 1K images. So there's not much detail even at this distance. A lot of what I do, I deal with 8K images, at least for the color and detail image, and I'll deal with a 4K mesh. The just to give me that a lot of that extra detail. So. But there we go. Okay, let's talk. Okay, I want to keep my light and cameras in place. I just want to clear mesher. Clear selected. And clear out the images. There we go. Okay. Once again, I'm assuming you have a good knowledge of Lightwave, and I'm not going to go into full, how to set up scenes and cameras and color and lighting and all that. Not in this video anyway. I'm focusing on getting you from Gaea into Lightwave and get something working there so you can start experimenting and rendering. So there we go. Let's grab that. And look at that. We've got our basic mesh. Now, if we render it now, let's do a quick Viper render here. It's wet. It's wet everywhere. And that's not the look we want. So, and the reason for that is the roughness is 10% over the entire landscape. It's the same roughness. We don't want that. Now, if I just take this mask and invert it, okay, that kind of works, but that's too much of a mirror. That's too still. It's too unnatural. It doesn't look right. And the rest of the landscape is has no life to it. It doesn't really react to the lighting and the sun that well. So, leaving everything else alone, what I want to do is I want to pull up a scalar here. I'm going to pull up a remap. Oops. I'm going to invert that back. Take it off. Now I want my base roughness to be about 85%. Okay. And that will be across the entire landscape. And what I will do is I'll adjust that until I get it where I like it. Yeah, okay, that's some shiny rocks. That looks good. So I call it 0.7. Okay. Now here, I'm going to subtract the mask from, I'm going to subtract this mask from the scalar, from my general roughness. But I don't want to subtract it all the way out. I don't want this white water to zero out the roughness entirely. So I need to remap this. So I want my lowest roughness. I want the water roughness to be about, I don't know, 5%. Sounds good. So I got a 0.7 is my scalar there. So this will be 0.65. Because I know that peaks at 1. That's a full 0 to 1. That's because the way the mask was set up in Gaea, or close enough to not matter at this point. And I can in the advanced tutorials I will show you how to guarantee that that's an absolute value, a specific value, or an absolute 0 or 1 value, which does come in handy when you're using it for instancing. So with that remapped, I need to subtract and subtract those out, and boom. Look at that. Still a little too mirrory for me, for my tastes. So let's make this, oops. No, actually, 0.6 gives me a little bit of roughness there. Yeah. It's looking pretty good. And that, ladies and gentlemen, is pretty much it. Save current object. I want to show you something about the quick aside here on the bump. Now, I set this to 5%, and I'm going to turn that off. Do a limited region here just so we can get quicker renders, and show you what happens with that detail map, both without it and with it, and then with it at 100%. So let's see, where's my camera? Camera 2. Set that to camera 1. My primary camera. Okay. This will render pretty quick. Okay, and that's with the bump at 100%. Okay, let me bring that in a little bit better so you can see. And a little extra detail there. And what's really noticeable when I do this, maybe not as noticeable at this resolution than it would be with higher resolution maps, but you can definitely see the difference here with, without. And then if I take this up to full 100%, which I don't really recommend for any bump map. I rarely will use any bump map that's provided to me at anything more than about 20%, and that's an extreme. I'm typically in the 5 to 10% range. That's really comes into play with the Megascans objects, and with stuff from Kitbash 3D. Most of those I'll stay in the 5 to 10% range, because they get really overpowered. Anything above that. So let's say that's 100%, And let's quick F9. And you start to see the artifacting, just the over pronounced bumps and things there. If that's what you're looking for, if you need that kind of that kind of detail, by all means, crank it up. This particular image, I might bring it up from the 5% that I had to maybe 10 or 15%, but definitely not all the way up to 100% because you start getting some weird artifacting in here, and some of that's as much the pixel blending as anything else. Because if I turn off pixel blending, well, actually, pixel blending may work better on this if you want rocks. But yeah. But that, ladies and gentlemen, is how you get data from the basics, how you get data from Gaia into Lightwave. I didn't cover the height map, which I can cover if anyone's interested. I can do another quick video on that. I will cover it extensively in the next series of videos on the full project work, because I use that for some, use it for oddly enough for adding detail back to the scene, because I'm working with 8K height maps and 8K data maps in that scene, but I'm only working with a 2K or 4K landscape. But there are ways to add data back, and add displacement data back in, when I have that much. I have so much more data in my height map than I have in my mesh. So that's it. Leave me comments. Catch me on Facebook. I'll leave links below to some fantastic resources. I am on I manage and run the unofficial Gaea Discord server, which I will link below. You can find me there. You can find me in the Lightwave Discord, server. As always, thank you all, and end of line.